Let us now consider how the choice of system affects how we apply the work kinetic energy theorem, so that way we can solve problems in a practical way. So firstly, we have the work kinetic energy theorem for systems, where we now understand this net work done to be the work done by all the internal and external forces on the objects in our system as our system changes from state A to state B, and this change in kinetic energy to be the sum of all the changes in kinetic energies of all the objects in our systems as our system changes from state A to state B. So to see how the choice of system affects how we think about things, let's use a simple example. In this example, we have the following scenario. A rock falls to the earth under the influence of gravity alone, and we have two possible systems that we can use to think about this scenario. Firstly, we have the system of the rock alone, which I have drawn here right now. In this case, the gravitational force of the earth is an external force, and it is doing work on the objects inside our system, the one and only object. If we applied the work kinetic energy theorem to this, it would look as follows. We have the work done by the gravitational force on the objects in our system, on our rock, is equal to mgh. Notice it is positive work because the force and displacement are in the same direction as our object moves from state A to state B, as our system changes from state A to state B. It undergoes a displacement h, and so we have h for the work done. This then is equal to the change in kinetic energy of our object, where VB is the speed of our object at B, when our system is at state B, when our rock is at position B, and this is the speed of our object at position A, when our system is in state A. All right, let's now consider the other system. In this system, the rock and the earth are both inside our system, so the gravitational force of the earth on the rock is now an internal force, and the gravitational force of the rock on the earth is also an internal force. Both of the forces are now inside our system and doing work on the objects inside our system. The work kinetic energy theorem for our system then looks as follows. Because the earth is now in our system, we have to add up the work done on it too. And so accordingly, I have split up the work done on the objects in our system. We have the work done by the force of gravity of the earth on our rock, and the work done by the force of gravity on the earth. This is the total work done on the system, and it'll be equal to the total change in kinetic energy, the change in kinetic energy of the rock plus the change in kinetic energy of the earth. Now note, the force of gravity of the rock on the earth doesn't move the earth. Its displacement is zero, so the work done is zero for the force of gravity of the rock on the earth. And for similar reasons, the change in kinetic energy of the earth is zero. It doesn't change its position, it doesn't change its speed, it just has the same kinetic energy before and after at state A and in state B when the rock is on the earth, because the force of gravity of the rock on the earth doesn't really do anything to it for all intents and purposes. Then the work kinetic energy theorem becomes as follows. The work done by the earth on the ball is still the same. It doesn't matter whether the force is inside or outside our system. The work done on the object remains the same. And so you see we have the same equation in system 2 as we found in equation 1. It is a general feature that no matter which system you choose, you will get the same physical results. So if you solve for physical quantities like displacement, mass, or speed, doesn't matter which system you choose, you will get the same value for speed, mass, displacement. In this case, the equations look exactly the same, and that's because the Earth, for all intents and purposes, is not moving. If it did, we'd have to include these terms, and this equation would become a little bit more complicated too for the work done by the Earth on the rock. But here you see how the choice of system affects how you think about your problem and how you apply the work kinetic energy theorem to the problem. Also, system 1, where all the forces are external to our system, is often the most convenient choice to make when applying the work kinetic energy theorem to solve a problem. And although it is getting a little bit ahead of ourselves, system 2, where all the forces are internal to the system, is often the most convenient choice to make when using conservation of energy.